We have seen in previous video on history of radar that how the electromagnetic waves find its application in detection of the object. This found a huge impact during the World War to identify the enemy aircrafts and take the countermeasures. Isn't it really amazing to know how we can use EM waves for calculating the distance, speed and direction of a target? So let's find in this video how these type of rotating parabolic antennas are used for the detection of the objects. So let's see what radar means. So radar is an acronym for radio detection and ranging. This means that the radio waves are used for detecting the targets and calculating the range of the targets. So most of the radars has the capability to calculate not only the range, but it can calculate the velocity, the direction of the targets, and also like the shape of the targets depending upon the received power. So that is meant by radar. So it uses the radio waves for detecting the target. Let's see the basic working principle of a radar. So most of the radar uses these type of parabolic reflector antennas because they have the high directivity and thus high coverage gain. So they will be transmitting the electromagnetic waves. So this parabolic antenna will be rotating in all the direction. So it has a huge coverage in all the direction and it will be transmitting electromagnetic waves in all the directions. So when there is any targets in the direction of propagation of this wave, depending upon the size, shape, material and orientation of these targets, the wave will be scattered in different directions. So some of the waves will be absorbed by the material and some will be scattered in different directions. So it completely depends upon the target size, shape, orientation and material. And the wave which is coming directly back to the antenna will be processed by this antenna to find out the range, velocity, and the directions. So the range is mainly calculated based on the time it take to travel from this antenna to the targets and then coming back. That is based on the round trip time, it is calculating the range. And the velocity is calculated based on the Doppler shift, and as this antenna is rotating, we know that in which direction the waves are coming back, so it can also calculate the direction. That's how it is calculating the range, velocity and the direction of the targets. Based on the type of the targets like the plane, car or the truck, there will be difference in the reflected signal power. So this will help us to calculate the shape of the targets. So this is how the radar display will be looking, and here you can see that the rotation of the parabolic reflector and these dot will be representing the targets. So this is how the usual radar display will be looking like. So this is the basic building block of the radar system. It will be having the transmitter processing system and the receiver processing system, and usually the same antenna is used for both transmitter and the receiver. So we will be having a duplexer here that it is acting like a switch to connect between the transmitter and receiver based on the transmitting state or the receiving state. So when it is in the transmitting state, it will be transmitting the electromagnetic waves, and when it hits on the targets, the reflected wave will be received by the antenna and this switch will be connected to the receiver system. So based on the round trip time, it will calculate the range, and based on the Doppler velocity, it will calculate the velocity of the targets, and depending upon the direction of the antenna it can calculate the angle. And in modern antenna systems we are using the antenna arrays, and digital signal processing is used to calculate the direction of the propagation of the targets. So in upcoming videos we can see more details about the antenna arrays and how we are calculating the direction of the targets using the antenna arrays. So this is the basic building block of the radar systems. We can mm, explore more details about the transmitter and receiver system in our upcoming videos. So let's see what are the main advantages of the radar. So radar is a detecting system, so it has to detect the targets at some distances. So let's compare radar with a camera. So if you are using the cameras, it has does not have the capability to detect the targets in rainy or foggy or night environment. But as these radars are using the electromagnetic waves, which has the penetrating capability through these environments, radar can be used in foggy environments, rainy environments, and night environments. So this is the main advantages of usage of the radar as the detecting systems. And let's see what are the some of the main applications of the radar. So one of the main application is air traffic control. So you may have seen this type of setup in the airports. So these the main purpose of this setup is to prevent collisions and organize and expedite the flow of air traffic. So they will be seeing which aircrafts are coming to their airport, and they can direct and redirect the aircraft to avoid the collisions. And the one of the main application of the radar is weather radar. Using the weather radar, it is easy to predict the wind, rain, and other catastrophic environments. And other one other application is marine radar. So these are the radar which are installed on the ship, so they can be used to detect other ships and land hazards to provide the collisions. Another application is police radars. So these are used to measure the speed of the moving objects. So it is usually used by the police to check the speed of the moving vehicle while conducting the traffic enforcements. Another main important application is in automotive radar. So this is one of the systems showing the radar placements in Waymo robotaxis. So here you can see that radar plays a crucial role in self-driving cars. So the radar can be used to detect the traffic in front of the car and back of the car, and based on that it can align the self-driving of the vehicles. Another important application is synthetic aperture radar. So this is mainly used for the remote sensing. So this is one of the image showing the surface deformation on a volcano. So by using the radar, it is easy to have a visualization of the remote area. So here you can see how the landsliding is happening in the volcano areas using the synthetic aperture radars. So I hope you get idea about what is meant by the radar and the basic principle and some of the applications. Thank you.